Hello there. Good morning from Vienna in Austria. Good to see everybody. Wherever you're tuning in from, I hope you're having the most wonderful day or afternoon or evening and just, gotten lots of rest. And well, here we are, the final lesson of the free JavaScript bootcamp that we've been doing for the last 6 weeks. Just as a quick reminder before we get started, just because today is the last lesson does not mean that we are done here. um, all of the materials will stay up. These recordings on YouTube will stay up. You'll be able to keep watching at your own discretion. Also, the FreeCodeCamp certification you can get at any time. We're just providing a framework here to help folks get there, but of course, you can do so at your own pace. This is a self-paced bootcamp. Also, just want to remind everybody that, Discord's going to stay here. The forum is going to stay here. The point is to continue collaborating, to continue communicating, keep asking questions, and all of that. And finally, tomorrow we won't have a guest session, but instead we're going to have a little wrap party. Jess and I are going to come on and bring over all of our fabulous mentors, Kiki, Galbrush, Kinjal, and we're just going to talk about what's next. We're going to talk about whatever y'all want to talk about, answer questions about software development, about web development, about JavaScript development. So that'll happen at 17 UTC. You should find it in your Class Central dashboard. If not, we will make sure it's there. But yes, that'll be 5 p.m. UTC tomorrow, the same time as the usual guest sessions have been taking place. Now let's see where folks are tuning in from. We got folks tuning in from Zambia, from Germany, good morning, from Barcelona, from Nigeria, from Shentendre, I hope I said that right, from the UK, from India, from New Jersey. My goodness. Hope it's not too late there. Remember, all of this is recorded and you can get some rest as well. From Belarus, love it. Love it, love it, love it. And well, yeah, thank you all for joining in. Thank you all for coming to the final session. Just a few links before we get started. We've got classcentral.com to get the dashboard and all your materials. FreeCodeCamp to get the learning materials themselves, and of course, the free certification. You find the forum where you can ask questions and answer questions, which, as you know, I'm a big fan of. You've also got a Discord channel where you can come in and talk more synchronously if you like. And of course, we've got a code of conduct that we expect everybody to abide by. If you have anything to report or any feedback, please send this to bootcamp@class-central.com. See where else folks are tuning in from: Melbourne, Austria, Nigeria, and the United States. Wonderful. Okay, well, let's hop right in and look at what we'll be doing next. Ooh, from Sudan. Hello, good to see you. All right. So let's catch up on homework first. Yesterday, we did some of the intermediate algorithms scripting, and by some of, I mean not a whole lot. But, that helped us get going with our algorithm understanding. Homework was to do the rest of that and also start taking a look at what we'll be doing today, which is the final project in the free JavaScript bootcamp and the JavaScript certification from FreeCodeCamp, which is the cash register project. Now, a couple folks have also asked me to take a look at some of the intermediate algorithm scripting. We'll do that during the Q&A session. But first, let's solve this project. Now, if you had the chance, it would have been great if you could have, had a look at it and start thinking about how to solve it. I saw some folks post on the forum about some ideas they had. Fantastic. What I'm going to be doing today is deriving a solution of my own, thinking about it, working with y'all to make it a little bit perhaps more better, or maybe explore some of your ideas and have a discussion about how to solve this problem. First, let's take a look at the code we have here on the right. We've got a function cash register, which takes 3 parameters: price, cash, and CID, a CID. We have a variable called change, and we return a variable called change. Then we call check cash register with a price, $19.50. With cash, which is 20, and then what looks like a two-dimensional array of pennies, nickels, dimes, quarters, 1, 5, 10, 20, and 100. Now, if you're not from the United States, if you're not living in the United States like me, these names of things, they correspond to coins, right? So pennies, for example, are 1-cent coins, nickels are 5-cent coins, dimes are 10-cent coins, and quarters are 25-cent coins. Then we move on to dollars, American dollars. $1, $5, $10 bills, $20 bills, and $100 bills. So that's what these are referring to. And it can be a bit confusing at first. I know definitely for me, I always forget which one a nickel is. Anyway, so cash register project. Let's read through here on the left and then start deriving our solution. Design a cash register drawer function, check cash register, we've got that already, that accepts purchase price as the first argument, payment as the second argument, and cash in drawer as the third argument. So we've got the price being the price of how much we have to pay to the cash register, cash being how much we paid as a cash register. Yeah, how much we paid, how much the person gave to the cash register, and the CID being the cash in drawer. So CID stands for cash in drawer. So if I'm saying CID, I'm going to be referring to the cash in drawer as a third argument. CID is a 2D array listing available currency. Yeah, we see that. The check cash register but function should always return an object with a status key and a change key. Okay, we start seeing some expectations we have. Return an object with status, insufficient funds, and change is an empty array if the cash in drawer is less than the change due, or if you cannot return the exact change. Okay, so if the total amount of cash in the drawer, in the CID, is less than the change due, or if you cannot return the exact change, if there are then we'll return insufficient funds. Cool. Excuse me. Return status closed and change being an array of stuff, with cash in drawer as the value for the key change if it is equal to the change due. So if the change that we need to give back is equal to the amount of change in the drawer, then we return this. And change here is just the value of the CID, which you remember is the cash in drawer. Otherwise, return status open and change being something, with the change due in coins and bills sorted from highest to lowest order as the value of the change key. So if we have enough money, if we have more money in the drawer than is due, then we'll return open and then how much money we're giving out from the CID. Now we've got it. Oh, nice. We do have a table. Okay, so penny is 1 cent, nickel is 5 cents, dimes are 10 cents, quarters are 25 cents, dollars are $1, $5 are $5, 10 is 10, and 20 is 20, and 100 is 100. See below for an example of a cash and drawer array. Now to clarify, when we say penny 10 and 101, this means that we have $1.01 worth of pennies in the drawer. That means that there are 101 pennies in the drawer. So far, so good. Nickels, we have $2.05 worth of nickels. It is too early in the morning for me to do that division in my head, but we have a lot of nickels. 31 dimes, right? Is that right? Yeah, that's right. We have 31 dimes. We have a couple quarters. We have 91 dollar bills. We have 11 $5 bills. We have 20 $10 bills. We have 3 $20 bills. And we have one $100 bill. Look at you, Michael, doing math much better than me. We have 41 nickels. There you go. Thank you. Okay. All right. So we got a lot to process in here. We've got this cash register, which goes from pennies, the lowest value, to $100 bills, the highest value. So let's just expand this a little bit so we have some place to work. And I'm going to start writing some pseudocode, as I always do. The first thing I want to do is calculate the amount of change due. Store variable with amount of change due. And I'm going to call this, I'm going to delete this code. I want to work on my own here. Then I will sum up all of the cents in the cash drawer. Money, not cents, my bad. So once we calculate the amount of change due, and once we calculate how much money there is in the cash drawer, we can already check for the first for our first condition to return. Because if the cash in drawer is equal to the change due, let me say that again. If the cash in drawer is equal to the change due, then if money in SID is the same as change due, return this. Status closed, change, and this should be the SID itself. Now I'm going to do something I don't usually do, which is, given this condition here, I'm going to start immediately implementing it. I'm going to give it a try. First, we've got change due. Now, how do we calculate how much change is due? Remember the parameters. We've got cash and we've got price. Price is how much we are expected to pay, and cash is how much we paid. Let's console log the, oh, actually, we don't need to. We've got them right here, 1950 and 20. So we're supposed to pay $19.50, and we gave them $20. So to calculate the change due, I will take my cash and subtract. I'll take the cash and subtract how much I have to pay. So cash minus price. Let's console log that just to be on the safe side. I believe we'll want to pay. We want to get 50 cents in change back. Now, before I go any further, folks, I want to teach you a fun fact about JavaScript, because the next thing I'm going to do is convert to cents. I'm going to put a big sign here, right away. Now, you might be wondering, why would you want to convert? First of all, how do we convert that to cents? Let's do that. Change due cents is going to be change due times 100. Change due cents. So we're going to want to give back 50 cents. But you're probably wondering, Ramon, why would we want to convert this to cents? It's all in dollars, not in cents. And that's because dollars are in floating point decimal numbers. And JavaScript is a little bit weird when it comes to decimal numbers. Fun fact, let's console log 0.1 plus 0.2. As Wangang says here, because floats are evil. So I don't know about evil, but definitely weird. Look at that. 0.1 plus 0.2 gives us 0. This. And you might be wondering, what? Why? what I will ask Galbrush to do, here's a big wink from me to Galbrush, please send a link, is to please post an article from FreeCodeCamp about why it is that we should always handle monetary values in cents. Because this is why. It's weird. So yeah, from here on out, we're going to be working in cents. Thank you, Galbrush. Next up, we're going to sum up all of the money that's in the drawer. Let's call this cash for change. And we're going to sum up all of the money in the drawer. The way to do that is we're going to use reduce. Good old reduce. We're going to use an accumulator. And let's see, if we're going to be going through the SID, we're going to be iterating over each of these. What would I call these? Money for type. No. What would this represent? What do we call this? What do we call this? They say that one of the most difficult things in JavaScript is naming things. In programming is naming things. Let's call this coins and bills. Coins and bills. Coin or bill. There we go. Coin or bill. Michael recommends elements, which is good, but it's not really descriptive, and I want it to be a little bit more descriptive this time. I think coin or bill. Currency sub R is pretty good, but it's not really a current. Well, I guess we're dealing in currency. Currency unit, money family. That's cute. I like it. Money family. Yeah, I mean, this is a family of money, but like for each individual one, I don't know. Coin or bill. Yeah, this isn't. Okay, hear me out. You know how in a cash register there are these slots. How about we call them money slots? Actually, I kind of like that. I need something generic just for the reduce function anyway. True, but if I can, I'm going to be as descriptive as possible. So, okay, money slot. I like that. Let's have our function. You know what, Carlos? I will, Pat. Thank you. Right. So we want to return the accumulator plus money slot. And I want to add up this one here, which is the second member of the array. Right? And I want to change this in cents. We're only working in cents. So times 100 right away. Don't want to deal with decimals. So really sum up all of the money in cents. Cash drawer. Cash for change, return accumulator. We need to start with 0. We're good. Let's console log that. So like this, we currently have 33,541 cents in the drawer. That sounds like a lot. Oh no, it's not that much. It's $335. Cool. Now we can already check if the money in the SID is the same as the change due, return status closed, change SID. So if change due cents is equals to the amount cash for change, we can return this already. Which I don't know about you, but is a little bit satisfying to know that we're already like fulfilling one of the conditions. Let's try it out. It should be closed, right? Let's see one of the tests that give us closed. Status open, insufficient funds, insufficient funds. Here's one. Should return status closed and all of the money. Let's give it a try. Check cash register. Of course, I'll need to console log that. So this is indeed giving us status closed because the change we have is, here, I'm going to make this a little bit wider again. We're giving in $19.50. We're supposed to pay $19.50. We're getting back, we're putting in 20, and in the cash register, there's nothing except for 50 cents worth of pennies. So 50 pennies. So since the exact amount of change is in the cash register, status is closed, and the change is the SID itself. So if I run the tests now, a bunch of them should fail, but this one should pass. Let's verify that. Yeah, a bunch of them failed. Hey, look at that. Okay, first condition passing, which is excellent, which is good. It makes me happy. It's a relief to know that at least we've got one of them. So what we're going to do now is start calculating how much money we can give out in terms of bills. So let's think. Calculate. Whoops. Sorry about that. So calculate how much change we can give based on bills. No, they're not bills. Slots in the SID. Cool. Let's read these conditions again. Return status insufficient funds. Change if the cash and drawer is less than the change due, or if you cannot return the exact change. Otherwise, return status open with the change due in coins or bills sorted from highest to lowest order as the value of the change key. And this is going to be a critical part here. Sorted in highest to lowest order. So far, the SID is sorted in lowest to highest order. So excuse me. First thing we're going to do is reverse the SID. And similar to how we did with the Roman numeral converter, we're going to convert amount of money into bills. We're going to build our own wad of cash. So let's call this const change cash. Change cash. Let's call this let's call this change in hand. Yeah. We'll reverse the SID. Then we will create an array of slots based on adding up for each slot the amount of money we'll pay with that slot. Hope that makes some sense. So we want to first reverse the SID. If you don't remember, let me just bring up here. Let's do a reverse. So what reverse does is it reverses an array. For example, array has 1, 2, 3. Array 1.reverse will give us 3, 2, 1. Cool. Carlos is suggesting, hey, why don't you take out the 0 slots? That's a good idea. I'll tell you what, let's save this. Let's bookmark this, and then we'll try it later. Yeah? It's a good idea, but I'll try it later. Cool. So we'll reverse, then we'll map. We need to create a map, an array, a two-dimensional array once again. And then we need the slot itself. Yep. And then an arrow function. There we go. So in here, we're going to do like we did with the Roman numeral converter and calculate how much money we can give out based on that. First thing I want to do is console log each slot, just so I know what I'm working with. Oh, hold on. It's not getting there yet because my current example is stopping here. So let me go back to the original example. Yeah. There we go. So here we go. We are starting with the hundreds, then going with the 20s, then going with the 10s, then going with the 5s, the 1s, the quarters, the dimes, the nickels, and the pennies. Which is good. What is it we want to do now? We want to get the value of that slot worth. That is, a penny being worth 1 cent and a $100 bill being worth 10,000 cents. So we'll do that. Then we will, let me think. We'll do the loop. While, while the amount of, money in that slot is available, is bigger than zero, and the value of the bill, the value of that slot. So the value of the slot, by the way, is like, a penny being worth 1 cent, a $20 bill being worth 2,000 cents. Is that right? Yeah, 2,000 cents is smaller than the amount of remaining change due. Let's do these first. Let's do these two parts first. So we'll get the value of that slot's worth. Ideally, I would have something like this table in my code, but I don't. So what I'm going to do is actually create an object so that I can look these up. And I can use the names of these as lookup for them, which is perfect. Let's do that. What do we call this object? Like a money table. So a penny is worth, now we're going to do this in cents. I'm going to do this in cents. So a penny is worth 1 cent. Nickel is worth 5 cents. Dime is worth 10. Quarter is worth 25. Dollar, oh no, it's 1, sorry. 1 is worth 100. I forgot my comma. 5 is worth 500. 10 is worth 1,000. 20 is worth 2,000. And 1, wait, is this a string? Is this a space? It is a space. So we got to do it like this. 100 is worth 10,000. Now that we've got that, we can get the value of that slot's worth, which is good. So, actually, we also want to instant the amount of money of that bill type as 0 because we want to cash equals 0. And we want to get the value of that slot's worth. Now, what are the slots again? Each slot is an array. Let's console log 110. So we can actually use spreading to get slot name, slot amount equals slot. Console log slot name. Now we've got those names of those dollar types, which is good. But if we're going to be doing this here, we might as well be doing it up here using the magic of spreading. So let's do that. Slot name, slot amount. So there we go. We got 120, 10, 5, 1 quarter, dime, and nickel. Now we can get the value of that slot's worth, which is const. What do we call this? Slot value is, we will use money table slot name. Slot name, slot value. There we go. Now now we've got access to what each slot name is worth. Fantastic. Next, convert amount to cents right away. Convert amount to cents. Yeah, we're not messing with decimal numbers here. Amount cents equals slot amount times 100. So that's how much, hold on, slot. So there's a 10,000 cents worth of 100s. There's 6,000 cents worth of 20s, 2,000 cents worth of 10s, 5,500 cents worth of 5s, and so on and so forth. Wait a minute. Nichols, what are you doing? Slot amount. Worth. Hold on. What if I? No, don't like this. What are you doing? Why are you doing this? How do we? Shall we round it up with math.round? Yeah. See, I see you, Nichols. I don't want to mess around. Whew, that was close. Good thing we checked. Okay, good. Now it's definitely in cents. Good. Awesome. So we're going to be calculating how much cash worth of this slot we're going to be handing over. And that's what this while loop is for. While the amount of money in that slot is bigger than 0, so while amount cents is bigger than 0, and that's not an ampersand, there we go. I'm going to check that the slot value is less than or equals to the amount of change remaining due. Change to cents. Cool. So as we're doing that, just like we did with the Roman numeral converter, we're going to check first that first we're going to add one slot's worth to the total. We're going to subtract that amount from the change due, and we're going to subtract that amount from to subtract that amount from the amount of cents available in that slot. First, add one slot bill's worth to the total. Then subtract that amount from the change to. Also, subtract that amount from the amount available in that slot. First things first, total plus equals the, what do we call it? The slot value? Oh, total cash, my bad. N. Change to cents minus equals slot value. Subtract, well, let me actually need more space. Thank you. Subtract that amount from the amount available in that slot. Amount cents minus equals slot value. Carlos is saying I'm lost in the names. That's not good. That means that we could use better names here. How about let's rename a couple of these because, yeah, calling so many of them something to do with slots can be confusing. Thank you, Carlos. That's good. That's good to be called. How about we call this bill or coin name? There. I think that's a little bit better. Slot amount. Let's call this one amount in slot. I think that's a little bit better. And slot value, slots. Bill or value, I think makes more sense. And amount in slot cents. Okay, a couple of things to change. First of all, this needs to be a let, not a const, because I'm going to be changing that. Jay's asking, can you go over yesterday's homework? We will be doing that during the Q&A. Absolutely. Somebody posted in the forum that they wanted some help with that, and I am absolutely here for that. So this is now going to be called this. Slot value is going to be bill or coin value, bill or coin value, bill or coin value, slot cents. Oh. Michael used term denomination. What does denomination mean? Sorry. Oh, Sandra's got a question. I'm not a native. I'm barely a native. But wouldn't it be better to use value in slots instead of amount in slot? Amount of 5 or for 15 cents would be 3 to me. Oh, that makes sense. Yeah, let's do that. Thank you. Michael says that the value of a bill or a coin is called a denomination. Okay, let's do that. I like that. So, denomination. I like this. This is collaborative. Denomination. 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 It sounds like domination, but it's denomination. Sandra, I love your suggestion. Let's do that. Value in slot. Value in slot, and this will be value in slot cents. We'll walk through this in slow motion anyway, so don't worry, folks. Okay, so we've added up how much money worth of each bill we're going to use, and we're subtracting that from the amount of change left. I want to take a second to console log that total, and I already forgot the name. Bill or coin name. Cash. When we're giving out change, remember that there are 50 cents of change due. So we're going to give out $0 $100, $0 $100, $0 $20, 0 10s, 0 5s, 0 1s, and 50 cents worth of quarters. We can do this because there are at least $4.25 worth of quarters, which is cool. So when I do that, I'm going to create my own cash in hand array with the bill or coin name and total cash. Unfortunately, it does have to be in decimals, so I will divide it by 100 here. So this map will get stored in a variable called change in hand. Let's have a look. Which is almost good, but there's actually one more thing we need to do. And this is what Carlos suggested. Filter out all, because I'm not giving someone $0 $100. I'm just giving them 2 quarters, 50 cents worth of quarters. So I'm going to filter out all the coin or bill types that have 0 money. I'm going to call this well, actually, I don't care about the name, so I'm going to use an underscore for that and the value. And I'm going to filter out all of I need to filter in the ones that have a value that is bigger than 0. Am I doing wrong? Oh, right. This needs to be inside brackets. Nice. Okay, that cleans it up a little bit. I also want to take a second to change due cents. Oh, look at Carlos suggesting that we use Truthy and Truthy1. In this case, I want to be a little bit more explicit because yes, 0 is Truthy. But what I really want to communicate to my colleagues who are reading this code is, hey, we want to filter out the ones where the value is bigger than 0. This is technically correct what you're suggesting, Carlos, but I think this one reads better. That's just an opinion, but I appreciate it. I love that y'all are giving me suggestions. There are no more cents due, which is good. That means that we can actually try one out. Oh, hold on. Return insufficient funds if the cash in drawer is less than the change due, or if you cannot return the exact change. And there's one way to check that. If there is still change due, we either don't have enough money in the SID, or our money types don't add up. And there's an easy way to check that. If the change due in cents is bigger than 0, well then, we'll return. Actually, we'll just return this. Insufficient funds. How do we check that? Let's look for an example that gives us insufficient funds. Ah, here we go. console log. Savarko says you're lost. I'm sorry, Savarko. I tell you what, we're nearly done. We're going to walk through this with the visualizer, and then we'll try out again. We have the time. So this is giving me insufficient funds. Why? Because we need to pay $19.50. We gave them $20, but the cash register only has 1 cent. That means that when we calculate, check it out. Okay, check it out. Console log. Console log cash in hand. What is it called? Change in hand. Sorry. See, we're only giving out back 1 cent because that's how much money we can give back. Change due cents is still 49 cents. Yeah? So we're returning insufficient funds. So that's good. We've got that working. Let's run some tests and see which ones are still missing. I'm just going to expand this here. So this one's still not working. Let's see which ones are working. This one with insufficient funds is working. This one with insufficient funds is working. And this one with closed is working. I'm going to take a second to explain this, to answer this question from Triple M. Could you please explain the parameters on line 53? Why are we putting an underscore here? And Saria is already explaining it much better than I could have. It's a placeholder because we don't need it if we don't give it a name. And it's true because remember, each cash in hand is, each change in hand is an array of a name and a value. And I just want to check that the value is bigger than 0. I don't care. We can call this floopy flu if we want, right? But in JavaScript, a nice way to tell the other programmers, like, I don't really care what this is. We can put in an underscore. We can put just a comma, right? I think we can. Oh, yeah. Or nothing. Yeah. Yeah, totally. We can just leave it out. Good point. I think the underscore is in other languages as well. That's my Elixir showing. Okay. So one more thing to do. If everything else looks good, otherwise, return status open and change with the change due in coins and bills sorted from highest to lowest order as the value in the change key. So since everything else looks fine, we can return status open with the change as change in hand. Let's try that out. For example, this one here. So we put in $19.50. No, sorry. We are supposed to pay $19.50. We put in $20. We get back status open with 2 quarters. Because remember, we go from 100 to 20 to 10 to 5 to 1 to quarters. We have $4.25 worth of quarters available. So we take those 2 quarters and then we're done. We just say, here's your 50 cents. With all that done, let's run our tests. Because I believe, unless I'm mistaken, that we're done. I'll just take a second to pat. And this was a lot, everybody. I would suggest, especially for this one, this is a nice example. Let's take all of this code and plug it into the Python the pythontutor.com visualizer. Did I put it in? Yes, I did. Cool. Let's visualize our execution. So Carlos says, you can now teach JavaScript. I absolutely think you can. So we've defined our function check cash register. We've also defined our money table. There's our money table, looking nice. Now we're going to console log the function of calling check cash register with price as 1950, cash as 20, and a SID, which if I scroll down, oh my goodness, that's a lot of things. Here's our SID with $1.01 of pennies, nickels, dimes, quarters, ones, 5s, 10s, 20s, and 100s. So first we calculate our change due. Sorry, one sec. There we go. Change due is cash minus price. 20 minus 1950 is 0.5, which we convert into cents, which is 50. Then we're going to sum up all of the money in cents in the cash register. So we're going to call that reduce in the SID. And for each one, we go money slot 1 times 100 plus accumulator. Accumulator is currently 0. So we start here with penny. So we take money slot 1, which is $1.01, multiply that by 100, which gives us 101. Accumulator is now 101. So then 101 plus $2.05, so 205 is 306. And we just loop through all of the money in the SID and accumulate it there using reduce. Almost done. What are we looking at right now? Let's see. Oh my goodness. I'm going to need a map for this. So we're currently at $20, which is 60 cents. $60. Then we do the 100s, and then we're done. So now this is how much money is available for paying change. Again, this is in cents. So we need to pay 50 cents, and we have 33,541 cents available. So is the change due in cents, which is 50, equals to the amount of money we have in the cash register? It is not. So we do not return status closed. Instead, we will reverse the SID and map over it to calculate change in hand. So we're starting with each bill or coin name. The first one is 100, and the value in that slot is 100. There is $100 in the 100 slot. So the total cash we're going to use for that is 0. We start at 0. Then we get the denomination from the money table. We give to it the bill or coin name. When we scroll up to our money table, we'll see that, okay, for 100, the denomination will be 10,000. Then we calculate how much value in cents is inside that slot. So we take the value in slot, which is 100, multiply it by 100, and in order to avoid any shenanigans, we round it down. What did I just do? What's going on? Oh no, what have I done? Unselect. Is it still working? It's still working. I'm sorry, I got confused. Sorry. So we're at the denomination. Where was I? Yes, of course. So we're looking at 20. I think I skipped. Oh, I can go previous, can't I? Oh, thank goodness. Sorry, folks. Okay. I got confused. So where was I? Yeah. Value in slot cents is 10,000. Okay. So I've gone back to where we were just now. Then we want to look at the loop. Is the value in slot cents value in slot cents bigger than 0? Value in slot cents is 10,000, still bigger than 0. Is the denomination smaller than the change due in cents? So is the denomination, 10,000, smaller than the change due in cents? It is not. So we will skip that loop. And we will move on to the next one. I'm sorry, no sé programar. Could you change the code using a link from the Python tutor? Link generator, I got lost when we changed the names of everything. Absolutely. That was my mistake. I shouldn't have changed the names of everything. I want it to be clearer. Next line to execute. So we're currently looking at the 20. Do you know what, folks? We've got some time. Let's rewrite this. Yeah, let's rewrite this. I want to do this. I'm going to reset all my code and we're going to start over from 0. Let's rewrite this. Yep. Let's rewrite it. Okay, starting from scratch. Again, sorry that I kind of jumped all over the place. I wanted to write some nicer names for things, and that ended up making things worse. So first thing we want to do is calculate amount of change due. First of all, so const change due is equals to cash minus price. Then we will convert that to cents. We change due times 100. So we're calculating how much change is due in cents. Cool. Next thing we want to do is sum up all of the money that's in the cash register. Cents in SID. Cents in SID. We'll do a reduce. We'll do our accumulator and call it slot. And we will return accumulator plus slot 1 times 100. So console log slot. We're going through each slot and adding up the amount of money in cents so that we get a nice big chunk of money there. Yeah. Console log cents in SID. Let's remove this console log here. 33541. Cool. Now that we know how much cents is due and how much cents we have available, we can take care of the first one. Return status close change with cash and drawer as the value for the key change if it is equal to the change due. So we can do that. So if cents in SID is equals to change due cents, then we could do return status closed and change SID. That's the first condition. Okay, this time I'm just gonna, I'm not ignoring any of y'all. I'm just gonna laser focus on getting this solution out first, and then we'll look at suggestions. Maybe that was my mistake. Next, we're going to calculate the change in hand. We're going to do that by creating SID-like array of, in reverse order, if I'm not mistaken, sorted from highest to lowest order. Because the SID comes from lowest to highest, we need to reverse the SID, which, let's console log that. Now we start at the hundreds and goes down to the pennies. Okay. Then we're going to map to create our own SID. So remember, each member of the SID is a subarray of a name and a value. So name and what do I call this? No, it's not a value. It's the value in slots. That's the name of the money type and the value in the slot. Start accumulating amount of money will give worth of that money type. That's how much money we're going to store of that type. Next, look up the amount that this money type is worth. Cool. Look at the amount that this money type is worth. Then we're going to loop while change. Folks are coming in and saying hello, everybody. So loop while the change. Let's see. While the change due is worth more than the money type is worth. And the amount that money type is worth. No. Sorry. Let me try this again. And while we still have money of that type in the drawer. Okay, so while we still have change to pay, and there is still money of that type in the drawer. Inside that loop, we will add one worth of that money to the total. Subtract from the change due and subtract that amount from the change due, the amount in the slot. Once that loop is done, we'll return name total. Actually, this can just be code. That was a lot. Let's go through each of these. So we started accumulating. There's our total. Then we need to look up the amount that this money type is worth. For that, we need our lookup table. Const. And I'm going to go with Michael's suggestion, denominations. So denominations, then we'll do for each of them. Do you know what? Let's see. It's just 1 cent. Nickel is 5 cents. Dime is 10 cents. I'm so bad at American money. Quarter is 25 cents. 1 is worth, how much was it? It's called 1, right? Yeah. 100. 5 is 500. 10 is 1,000. What else we got? 20 is worth 2,000. And this needs to be a string because it has a space. 100 is worth 10,000. There we go. So there's our denominations. Now let's go back. Look up the amount of this money is worth, also known as the denomination. Cool. So const denomination equals denominations, and we'll look. What have I? Did I just? I think I just pressed a magic key that told everybody what keyboard I'm using. That was weird. Anyway, we need to look up. Here we go. Denominations name. That'll tell us. Yeah, there's our name, and the denomination is 100, 2,000, and so on and so forth. So next, while the change due is worth more than the money type is worth, and while we still have money for that type in the drawer, so while change due is worth more than the drawer, and this is similar to when we did the Roman numeral converter. So while the oh, hold on a minute. We still need to get our value in cents. I forgot about that. Get the value in the slot in cents. So const, let's let value cents equals, what was it? It's just the value times 100, right? My brain is melting. Value, what's it called again? Value in slot times 100. Now I can do value cents is bigger than 0. And the value, the name, the denomination, and the denomination is less than or equals to the amount of change that is still due. So while we're doing that, we can do all three of these things. So add 1/4 of that money to the 1/4 of that, not money, but denomination. There we go. So total plus equals denomination. We're adding 1 bill. Then we are subtracting from change to cents that denomination's worth. And finally, we're subtracting that amount from the amount in the slot. So value cents. Now, if we were to visualize denomination, denomination. If we were to visualize this, let's say we have 10 $1 bills, right? And we owe $10. Sorry, 10 $1. Yeah, we owe $10 in change. What we're doing is essentially taking that stack of $10, of 10 $1 bills, and going, okay, here's one $1 bill. This is the total of money you will get from me. That is $1. I now owe you $9. Hold on, let me. So first, here you go. Here's $1. I now owe you $9, and I have $9 left of $1 bills. Then we check. Okay. Do I still have money available to give you? Also, is the amount that $1 is worth still smaller than the amount that I owe you, which is $9? So is $1 less than $9? Yes. Here's another $1. Now I'm going to give you $2. I now owe you $8. And I have $8 left. Look at Carlos. Having all the right answers. Yes, that makes more sense. Total, change due, cents, and value cents. And you know what? Let's put name there while we're at it. So we get to the quarter. Yeah, the first quarter we've given out. you have 25 cents worth. I still owe 25 cents of quarter. I still owe 25 cents, and I currently have 400 cents. By the time I give you another quarter, you now have $50, 50 cents, and I owe you 0 cents, and there are now 375 cents worth in the slot. This is fantastic. Thank you, Carlos. See, I've spent this entire bootcamp touting the need. I've spent this entire bootcamp like touting the need of the console log, and then I forgot to use it. Once I do this, and this map is done, let's console log that change in hand. Michael, I see your suggestion, but I'm not like the last time I made code changes, I got everybody confused. So I'm just going to stick to what I'm doing. Just for now, I'm not ignoring you. So here's our cash in hand, our change in hand. We got 100, we got 0 100s, 0 20s, 0 10s, 0 5s, 0 1s, and 50 cents worth of quarters. But of course, this should not be in cents. This should be in dollars. The thing I forgot to do was to divide that total by 100. Now we're back in dollars. Just a short reminder, if you're wondering why I'm doing this in cents, I recommend checking out this article here. And in case you're curious, let's see why I'm doing that. (0.1 plus 0.3). Sorry, 0.1 plus 0.2. This is why. This is why I would rather use cents. Check out that article. Let's see Sandra's question. I get the looping from line 37 to 44, but where do we tell it to go through the different types of money, penny, dimes, quarters? And as Tserie says, we did it in the sid.reverse. Here, I'm sorry, it's a bit hard to see because I've got it so zoomed in, but that's so that folks can read it. We did a map. So first we reversed it, and then we're doing a map. And that map, remember, from functional programming, loops through all the members of the SID. And it returns an array. Change in hand. That's why we do the hundreds. In fact, console log name total. You'll see, okay, first we tried with the hundreds. There's no hundreds. We tried with the 20s. There's no 20s. We tried with the 10s. There's no 10s. With the 5s, there's no 5s, and so on and so forth. In fact, we can also see value. What's it called? Slot value? Is it called slot value? Value in slot. We had $100 worth of hundreds, but we gave out 0. We had, because we only owed 50 cents. We had $60 worth, and we only gave out 0. We had $20 of 10s, we gave out 0, and so on and so forth. All right. Now, if I return console log change in hand. By the way, folks, I realize I'm going over time. We're still going to spend some time doing Q&A. Galbrush, if this is stressful, please, don't worry, I can handle it. Like if you need to go. Yeah, right. So we've got our quarters, but really we only want to have the ones where we have money. So I'm going to filter out the other ones, the ones with 0 in them. We can do that with a filter call. And we're going to filter through each of the changes. So we're going to use spreading to get that value. We're going to filter out the ones that have a value bigger than 0. I have once again made this mistake where I need to put parentheses. Console log change in hand. So now that I've filtered out all of the ones that are not with a value of more than 0, I'm left with my quarter. Now to the conditions. Return status insufficient funds if the cash in drawer is less than the change due, or if you cannot return the exact change. So that means, essentially, if I still owe change, we don't have sufficient funds. And because I have been subtracting from change due all this time, I can keep track of how much change I owe. Console log change due cents. I owe 0 cents in this case, but I still need to make that check. If change due in cents is bigger than 0, that is, there is still change due, then I will return this. Insufficient funds. Let me just make this a little bit narrower. So we'll return insufficient funds and that change, which is empty. We're not giving any change. If all other cases are equal, then we'll return status open and the change with our change in hand, with the change due in coins and bills sorted in highest to lowest order as the value of the change key. Return status open, change in hand. Console log our results here. So because we have enough money in the change in the cash register, we return status open, and we're giving out 50 cents worth of quarters. 19 that we're supposed to pay with the 20 that we gave them means that we're getting 2 quarters in change. Let's run our tests. That's working. We'll pat ourselves on the back. Pat, pat. And before we go any further into Q&A, now that we've completed 100% of the projects, we get a nicely done. You have completed JavaScript algorithms and data structures projects. Become a monthly supporter of our nonprofit. Again, this is, open source, nonprofit organizations. We will, can, if we want, donate a couple bucks a month. What they do is extraordinary. I give them some money on my other account, but if you can't afford it, please do not feel stressed too. You can come back later and donate a couple bucks. It's totally fine. I'm doing so on another account. This one has to be empty so that I can show you how to get your certificate. Because yes, we need to get our certificate now. Oh, sorry, I had that still open. So, in order to get our certificate, let's scroll all the way down. Click here, go to the settings to claim your certification. Click on that. Now we need to go to the course that we just did. So not responsive web design. If you want to do responsive web design, my friend Jess, who's a great teacher, is today wrapping up a bootcamp on responsive web design. It is fantastic, but we're going to be checking this one here. So we can check our solutions for our projects, but we can also claim our certification. So click here. To claim a certification, you must first accept our academic honesty policy, which I didn't do. That was my bad. So we can see here, academic honesty policy. And, you're just saying here that you're not plagiarizing. I hope you're not plagiarizing. I trust you all to be doing your own solutions. Click on agree. You have accepted. And Click on claim certification. At Ramón Huidobro Bootcamp Fall 2022, you have successfully claimed the JavaScript algorithms and data structure certification. Congratulations on behalf of the FreeCodeCamp.org team. If you click on show certification now, you will need to make your portfolio public. So a lot of settings. Let's do that. So where is that? Here in the settings, profile is public, name is public, public. There we go. And scroll down. Show certification. Let's just check that again. Well, you can see this message. Congratulations on earning the certification. It's no easy task. Running FreeCodeCamp isn't easy either, nor is it cheap. Help us help you and many other people around the world. Again, if you can, fantastic. And here we go. As of October 12th today, this certifies that Ramón Huidobro has successfully completed the FreeCodeCamp.org JavaScript algorithms and data structures developer certification, representing approximately 300 hours of coursework. This is a link that you can post. And here's what I want to ask you folks. If you're on social media, if you're on Twitter, if you're on LinkedIn, show it to us, send it to us, show off that certification. You have earned this. If you want, you can tag me. My Twitter handle's here at Hola Soy Milk. Totally fine. Absolutely go for it. You have earned this. I want to go back to Sandra's question. Seeing your solution makes perfect sense, but it's very hard for me to divide such large tasks into manageable chunks. Any tips on that? And I think this is a great question, because if we go back to the cash register problem real quick, I don't know if you noticed, but I divided and conquered. First, I focused on this one, insufficient funds. Just that. Just checking that there is enough money in the cash register to be able to do that. Once that was done, my next objective was to calculate how much change I'm going to give out. I'm not worrying about this stuff here. Not worrying about any of that. Just focusing on how much money in terms of which bills am I going to give out. Once that's done, what I can do next is focus on, okay, sorry, not this. Yeah. So focus on, the return status codes, then focus on getting the amount of money's worth. And you see what I'm doing here? I'm breaking down the problem into smaller problems. This is one part of it. Can I make a very guilty admission? Another thing that I do is I talk it out loud. The only reason that I've been able to do this with all of you semi-smoothly is because I'm talking out loud. And talking out loud is a really solid way of learning, because it allows you to, it forces your brain to start sort of like molding in your head how you're going to do stuff. I highly recommend writing stuff down. All of your learning you can write down, be it a blog. Write a blog post detailing what you've learned. You might think, oh, but Ramon, everybody talks about arrays. Yeah, but nobody talks about arrays in your perspective, and your perspective is important. What I always tell people is, yes, I've blogged in the past about what it was like to learn JavaScript in 2010, but only you have I don't have the perspective of learning JavaScript in 2022. You do, though, and that's worth a lot. Jeremy's got one here. Talking out loud is called rubber ducking. Of course, you've got a rubber duck on your desk. Do I have a rubber duck? No. I do have this very cute half penguin, half dog. I like it. Sorry, completely irrelevant. Look at Carlos saying it. When I speak about a problem with other person, doesn't matter who, I start to understand the questions and see some solutions. Love it. Folks, what happens next? Next, we will have tomorrow a sort of like wrap party where we'll have all of the mentors and Jess and myself to answer your questions about anything. First. Second, the Discord and the forum will stay open. All of these videos, all of these lessons we've done will stay recorded on YouTube. I will still be in the forum. I will still be in the Discord. I'm not going anywhere. This is a self-paced bootcamp because my last live stream ends tomorrow does not mean that you're supposed to finish the bootcamp in 6 weeks. Let's see, what am I missing? I'm missing Q&A, aren't I? And I want to do Jane from the forum a favor because she asked me in the forum if I could do the DNA pairing exercise. In the meantime, folks, please write your questions into the chat. Oh, Sandra, I'm really happy that talking out loud might help you. And this goes YouTube videos, streams, blog posts, etc. Sorry, back to the exercise. DNA pairing. So, oh, great. Yes. Thank you, Brett. I'll get your question next. Pairs of DNA strands consist of nucleobase pairs. Base pairs are represented by the characters AT and CG, with each form building blocks of the DNA double helix. The DNA strand is missing the pairing element. Write a function to match the missing base pairs for the provided DNA strand. For each character in the provided string, find the base pair character. I'm out of water. So, return the results as a 2D array. For example, for the input CGC, return GC, CG, and GC. The character and his pair are paired up in an array, and all of the arrays are grouped into one encapsulating array. Okay. So, listen, I've been talking for a long while. I ran out of water. Now I'm thirsty. Anyway, yeah. So what do we want to do here? We want to go through each letter and give it its corresponding DNA pair, base pair. So we can see here what the pairs are. For every A, we get a T. For every T, we get an A. And for every C, we get a G. And for every G, we get a C. That sounds to me like a switch statement. Let's give it a try. So start up an array, loop through letters in string. If it's A, add A, T. If it's T, add T, A. If it's, I did this wrong, G, A. If it's G, add G, C. If it's C, add C, G. And we want to return result array. Cool. Let's do it. Start up an array. Const result equals empty array. Loop through the letters in the string. So for let letter of string. Now we'll do a switch statement because we got just a bunch of these. Switch letter. Case A. No. Case A. Result dot push. Subarray of A. I'm just going to copy paste this because I'm lazy. Yeah. Break. Case C. You know what? I'm going to copy paste this a couple times because I'm lazy. If it's T, we return TA. If it's G, we push GC. And yeah, if it's, oops, if it's C, turn CG. And that's it. We then return the result array. Return result. Console log. So for GCG, we get GC, CG, GC. If we add an A in there, that'll give us GC, CG, GC, AT. Let's run our tests. Looks good. We'll pat ourselves on the back, a little pat. However, a loop with an array? Are you thinking what I'm thinking? Let's do a map instead. Yeah. Return string.map. Letter. And let's take this a step further. Let's have a lookup table. Base pairs. A, T, T, A, G, C, C, G. So we will return array with letter and base pairs letter. Oh, I can't map over a string. Well, that's disappointing. Oh, well, I guess we'll split it. Hey, look at that. I like that. Oh, I like that a lot. Oh, that looks so good. Oh, my goodness. GC, CG, GC, AT. Nice. That's fancy. I like it. I like it a lot. Run our tests. Still looks good. That's a pat as well. Okay. Question from Brett. How would you solve the search and replace exercise in the intermediate algorithm scripting? Well, first, I will need to take a look at the intermediate algorithm. At the search and replace. Let's see what we got. Perform a search and replace on the sentence using the arguments provided and return the new sentence. First argument is the sentence to perform the search and replace on. That's str. Second argument is the word you will be replacing before. Cool. Third argument is what you will be replacing the second argument with after. Note, preserve the case of the first character in the original word when you are replacing it. For example, if you mean to replace the word book with the word dog, it should be replaced as dog. Okay. So, if the first letter of before is uppercase, change after the first letter to uppercase. If the first letter of before is lowercase, change after's first letter to lowercase. Yeah. Then we want to replace. String.replace before with after. Console log. So a quick brown fox jumped over the lazy dog should replace jumped with leaped. Let's give it a try. A quick brown fox leaped over the lazy dog. However, if this is uppercase, for example, a quick brown fox leaped over the lazy dog, the leaped should be uppercase as well, which it is not. So if the first letter of before is uppercase, change after's first letter to uppercase. So we need a regular expression. Good old regular expressions. We need to check that the first letter is an A to Z uppercase. Check that the first letter is a capital letter. If the first letter is uppercase, then before equals. How do we do this? We need to split it up. Const first rest equals, equals after. Does that work? Console log, sorry, rest. Yep, yeeped. And first is a letter. Nice. Cool. So we've split up the string to have the first letter and then the rest of the letters. So far, so good. Then we need to make the first letter uppercase. First upper, first to uppercase. And we want after to be equals to first upper plus rest. There's a problem. Quick brown fox leapt. The problem is this is still an array. Rest is still an array when I did this splitting. So I need to join them. Hey, that's nice. Cool. Let's do the same here. So else if first letter of before is lowercase. So we'll do the same regular expression again. First letter, A to Z, test before. We'll do the same thing. First rest after. First lower equals first to lowercase. After equals first lower plus rest dot join. Let's give it a try. Oops. Okay, cool. So we're replacing lowercase jumped with with uppercase leaped, and that turns it into lowercase. Let's give it a try and see if the tests are passing. Yeah, we did it. That's a pat right there. It's a good question. Thanks, thanks, Brett. Any other questions? Oh, Pramod is asking. What is the best way to retain knowledge gained through this bootcamp? I tend to forget the concepts that I learned if I don't keep practicing on them, and I want to break into programming. If I may recommend, Pramod, have a look at the other things that FreeCodeCamp are offering. For example, data visualization, relational databases, backend development. There's also plenty of other resources like, I really like Exorcism. Hold on, exorcism.org. Put a link into the chat. What I like about this resource in particular, let me just make this larger, is that you can keep doing these exercises in different programming languages, but You can also give feedback, and I highly recommend giving feedback. You know how I was talking about putting words to thoughts before, about like saying stuff out loud, giving someone feedback on their code, like all of you have been doing to me for the last 6 weeks. Now you can do it in an open source platform for free. I love Exorcism. I did put the link, right? Yeah, cool. Let's see what else folks are saying. Carlos is recommending checking out spaced repetition. It's super helpful. Triple M agrees. Practice and start building more small projects and see how things connect. If I may recommend, now that you've got JavaScript under your belt, go check out HTML and CSS. Go check out Node.js. Here, Node.js. One sec. Go check out Node.js and start thinking about ways you can automate things for yourself. Practice. Write stuff out loud. What I always tell people, the way to know that you are, Sensor's recommending Code Wars. That's a good one. It is very tempting early in our learning careers to get stuck doing tutorials forever. Once you feel that you can start building stuff without the need of a tutorial, that is a very good sign that you're ready to start looking for work as a software developer. Let's see what else. I saw another question. Did I see any other questions? Somebody was asking. Sorry, I got a little lost in the chat. Let me see if there's anything else. Timmy feels recommending LeetCode. Thank you. Didn't know about that one. I think we're out of questions, folks. Did I forget something? How would you do this one? You know what? Just for fun, let's do one more intermediate algorithm, because those are hard. Plus, I'm going to miss you all. I'm kidding. I'm going to be here. How about we do arguments optional, drop it. Let's do the next one, missing letters. Find the missing letter in the past letter range and return it. If all letters are present in the range, return undefined. Oh, I like what Zenzer's saying. Following tutorials could turn into a vice. Yeah. Getting stuck in learning forever can be tricky. And I recommend being conscientious of the fact that, hey, am I learning just because I want to just keep learning, which is fine. And a lot of software development involves learning, but instead of learning instead of like moving forward, it's a tricky line to tell. Come over tomorrow when we're going to have our wrap party with Jess and the mentors. Bring that question along, because Jess is going to have some amazing answers as well. All right. So we've got letters. So we want to check that each of these letters, find the missing letter in the letter range and return it. Okay. If all letters are present in the range, return undefined. Returning undefined is the same as not returning. So we've already, if not present, if not missing, return nothing, i.e. undefined. We're already done there. So how about loop through the letters? Check that the char code, remember char codes, corresponds. If it doesn't, there's our missing letter. Let's do it. Let's get a bunch of char codes. So I don't remember how to turn something into a char code. Char code at. at a given index. Cool, cool, cool. Can we use a map for that? 4. Let letter of string. Wait, indexes. Let I equals 0, I smaller than string.length, I plus plus. I'm probably going to mess this up big time. So const char code equals string position I. Oh, what was it again? String dot char code at. Yep, 97, 98, 99, 100. String must be equals to string.length. If char code plus 1. No. If char code plus 1 not equals char code at I plus 1, return string char code plus 1. Is that correct? Console log. Let's return B. So if the next letter does not correspond, so the next letter in order does not correspond to the next letter in the string, then we just return that next letter. Let's give it a try. Nope. What happened? We got all the way to the end and it should return undefined. What did it return instead? A bracket. Okay. That's because we made it all the way to the end and it checked that the next letter was not a bracket. What if instead, if char code plus 1 is equals to curly bracket, just break out of the loop. Is that cheating? Let's find out. It is not. That's a pat right there. I think we're going to leave it there, folks. Oh, Michael says, yeah, you need to check that there's a next letter. Sandra's asking, couldn't we just stop at length minus 1? That's a good question. Let's find out. String.length minus 1. That is much better. Thank you, Sandra. Yeah. Cool. Thank you. I like that. That's a pat right there. Okay. Well, I think we have reached the end. Quick reminder. We've got the let's see. We've got the forum, we've got the Discord. This will stay on YouTube. Come over tomorrow, 5 p.m. UTC. Come hang out. I wish you all the best on your programming journey. As Mitch said, I agree. Good luck on your programming journey, everyone. And keep at it. I want to just recommend and suggest, if you get frustrated, it is absolutely common. It happens to everyone. I get frustrated programming. One of the best tricks to solve that is to take a break, if possible. Everyone gets stuck. I get stuck. People who've been coding for 10 years like me get stuck. It is absolutely common. So again, quick favor, go to your settings. If you already have your certificate, post it. I want to see it. Put it on LinkedIn, put it on Twitter, whatever you like. Post it and let me see it. I want to see it. I wish you all the best. And congratulations on making it to the end of this bootcamp. Everybody have a wonderful day. Get lots of rest. And I'll see you at the next one. Take care, everybody. Bye for now.